No, 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 no. Okay, we're talking about congruent figures in 4.1. What does the word congruent mean? When you see congruent, what do you guys think? Yeah, okay, so they are figures. Now we're talking about congruent figures. So figures could be triangles, they could be quadrilaterals, they could be pentagons, hexagons, they could be anything. They could be polygons, right? If we're saying congruent figures, then of course they have the same size and they have the same shape. And that's something that we've covered before. One thing to note here is we're gonna know this by the way that they are labeled. Okay, so I've got a quadrilateral there, and I have all four sides of the same. So let me ask you a question. Are these two figures, are these congruent figures? Would you say that those are congruent figures? Yes or no? Yeah, those would be congruent. Does it matter that that second one is turned sideways? No, it does not matter at all. Okay. Okay, I'm gonna pick a different color for you now. I'm gonna pick pink, and I'm gonna draw this triangle here, and I'm gonna draw that triangle there. Are those congruent figures? Why are those not congruent figures? They're not the same. They're not the same size, okay? So these right here, those two are not congruent. So not congruent. And of course, my green ones that I start off with, these ones are congruent. Yes, those are congruent. Alright, so when figures are congruent, this is going to be a super important concept, okay? So pay attention to this one. When figures are congruent, corresponding sides and corresponding angles are going to be equal to each other. So what do I mean by that? So let me draw a figure for you as best that I can. Okay, I'm going to draw the same figure here. We're going to call this figure A, B, C, D, and E. And then I'm going to draw this figure over here. Not a very good drawing, but you did it. F, G, H, I, and J. Okay, if these two figures are congruent, which I've tried to draw them as best I can congruent, so I'm saying these figures are congruent. So what that means is this line segment here, line segment EA. Which line segment do you think EA corresponds to in the other figure? Take a guess, just shout it out. If I said E to A, then I have to say J to F. In this case, the order in which I say it matters. All right. So how about this one? If I say D C, which this is I H, right? Yeah, there you go, right there. Those are corresponding, right? Those are the corresponding. So what do I mean by corresponding? In the same place, in the same location, right? Okay, in the same spot. Okay, so what if I do ED? Which one is corresponding to ED? Yes, this one corresponds to it, right? Now, let's talk about angles for a minute. Okay, what about this angle here? Angle B, which one does it correspond to? Angle G is over there, right? What about this angle here? Angle E. It corresponds to angle J. So, all these things are congruent if and only if those two figures are congruent. So, each of the corresponding parts is congruent to the other corresponding part in the other figure, if and only if the two figures, whatever they happen to be, are congruent. So here's what we can say. We can say a whole bunch about this particular figure. We could say that AB, segment AB, is congruent to FG. So that little arrow there going back and forth, it looks kind of like the if and only if symbol, except with only one arrow. That's going to represent corresponding, right? So AB corresponds to FG. What does BC correspond to? GH, very good. What does angle E correspond to? Angle J, very good. And what about angle D? What does that correspond to? Angle I, right? I mean, I could keep going, right? I keep going until I figure out all of these things. But the whole idea here is that if the figures are congruent, then corresponding sides and angles are also congruent. Okay, so when we're talking about congruent figures, the order in which we label things definitely matters, all right? So if I told you this, if we were told that triangle ABC is congruent to triangle EFG, if I know that, here's what I could not say. Okay, so if this is what I was given, it would be wrong for me to say this. Triangle ABC is congruent to triangle FGE. Okay, why would that be wrong? Yeah, what do you think, Jake? Yeah, they changed up the order. If I called this one first, right, and then I said this one second, and then this one third, right, and I was going like this in that order, then I have to go over here and start from that same exact order and go that way. So the order in which we say it matters. We're not allowed to say anything else. So this one is not good because it's out of order. So you must match corresponding parts when you list a congruency. So we should write that down for us. We must match corresponding parts when listing a congruency. Okay, so if we know triangle ABC is congruent to triangle DEF, then I know a couple of correspondings. So what is corresponding? Name the corresponding sides. I'll give you the first one. AB corresponds to DE. Can you give me the other two? If AB corresponds to DE, give me the other two. There you go. BC has to correspond to what? EF. Very good. Okay. Give me the third one. Do you guys see it?
You're looking at AC.
So look, I did this one. I did AB corresponds to DE, and then we did BC corresponds to EF. What's the other one?
AC and D.
There you go. AC has to correspond to what? DF. There you go. Do I have to draw the picture? No, I don't have to draw the picture because I know that the order in which they are congruent matters. So A, B, C congruent to D, E, F, then I can name the corresponding sides. Can you then name the corresponding angles? Here, I'll give you the first one. Angle A corresponds to angle D. What do you got?
Angle B corresponds to angle E.
Angle B corresponds to angle E, absolutely. And then the third one, anybody shout it out. Yeah, angle C corresponds to angle F. Okay, when you see figures in this section, you're going to see figures that are drawn together sometimes. So we have to be able to label that particular side. So, see this figure I have right here for you? One of those sides is the common side, and I'm not trying to trick you at all. Which side do you think is the common side? Yeah, what do you think, Adrian?
The middle.
Yeah, it's this one that I'm going to highlight. It's actually the side that they share. That's what that means. So I'm not trying to trick you at all. This is when the reflexive property comes into play. Okay? They are sharing the same side, so therefore they must have the same shape and they must have the same size. They must be congruent if it's congruent it's congruent to itself, right? It's the reflexive property in full form here. So the common side is the side that they share. It's that part, not trying to trick you at all. Okay, here's the big theorem of the day. I've already alluded to it a lot in the lesson, or for this particular section. If we're given that triangle ABC, the one on the left, is indeed congruent to triangle DEF, the one on the right, okay, then here's what we know. If we're given this stuff, then we can say all corresponding parts are congruent. Okay? That's the big deal right there. All corresponding parts are congruent. So what do I mean by that? I mean that angle A is then congruent to what? Angle D. Good. I know that angle B is congruent to what? Angle E. I know that angle F is congruent to angle C because they're corresponding, right? I know that side AB is congruent to side what? DE. Very good. I know that side CA is congruent to what? FD. Good, because the order matters that we say these things, right? I know that side BC is congruent to what? EF. Side EF, okay? So the actual thing that we say in the theorem is this. No, what we say in the proof is this. We say corresponding.
Can we draw that arrow now that we know that means corresponding?
parts. No, yeah, that means congruent. The arrow means corresponding.
Yeah, can we write that instead of like writing corresponding out of our...
No, because we say corresponding parts of congruent triangles are congruent. Okay? This right here, this is the big idea. And this cloud right here. Corresponding parts of congruent triangles are congruent. That's what we have to say in the proof for the reason. All that phrase right there. Isn't that crazy? Here's what you can put instead. You can do this. See all these letters I'm underlining here? See those letters? They stand for this. C, P, C, T, C. That's what you can actually put on the reason. So you gotta get to abbreviate that. That is universal geometry right there. Everyone understands CPCTC. It means corresponding parts of congruent triangles are congruent. Or you could write it, but I guarantee you most people are going to choose that option when we do like 5 or 6 of these proofs. Okay, here's an example. Given triangle TOM is congruent to triangle KAY, give me 6 parts that you know are congruent. What are the 6 things that you know that are congruent? Okay, angle O is congruent to angle A. What else do you know? Angle M is congruent to angle Y. What else do you know? Those are 3 things. What else do you know? Yeah, give me a side. Side TO is congruent to what? KA, very good. What else do you know? OM, yep. Is congruent to AY, absolutely. What else do you know? TM is congruent to KY. Those are the 6 things. Okay, last example here. Here's a figure. Triangle PXY would be congruent to what? How would we label it in the second triangle? PXY, what would it have to be in the second one? Say again? TXY, there you go. It'd have to be labeled TXY. And then, okay, is segment XP congruent to XT? If you know this statement is true, if you know that's true, is XP congruent to XT? Why are those congruent? No, that's not a common side. CPCTC. Yeah, there you go. Corresponding parts of congruent triangles are congruent. Okay. What about this angle here? Angle 1 and angle 2. Are those congruent? Yes. Why are those congruent? Because CPCTC.
You don't ever use common side for anything.
No, you do use common side for something. Okay. Yeah. Which one is the common side?
The middle one.
The middle one. That's the common side. Yeah, we are going to use common side for something.